Welcome to Feature Fridays. My name is Guy Bartram. I'm Director of Product Marketing for our cloud providers at VMware. And today joined by Joerg. It's been a little while, Joerg. Welcome back.
Yep. Thank you.
So why don't you just tell people who you are, Joerg, and what you do?
Yeah, I'm Joerg. I'm a technical product manager in VMware's cloud service provider team. And today I hope to demonstrate you some about the new features in the Terrafrom provider that we have.
Yeah, let's talk about that. So Terrafrom 3.9 was released, I think it was back in April, late end of April, and brought in some new features. There was actually, for the first time ever, there was a beta on 3.9, which was kind of new. And what was the thought process behind that, and how did that affect the release, do you know?
Yeah, so usually the Terrafrom provider is an open source project that is managed on GitHub, and we will show the GitHub repository later in the demo. It is maintained and sponsored by VMware, so it's a VMware engineering team behind that who's doing most of the code development and merging the code and planning and doing the releases. However, since it is an open source project, we get a lot of contributions actually from partners and even end customers as well, in terms of course, feature requests and bug reports, but sometimes even code contributions that then are being merged. And with since Terrafrom itself is a third-party product that's maintained and published by HashiCorp, another company, they pull in the releases and the tagged and marked releases from the GitHub repository into their mechanism. We will see later in the demo that it's actually very easy, single command line commands to use Terraform. And when you use the third-party provider from a Terraform perspective, you define that in the Terraform configuration file, and then the Terraform binary will automatically download the specific version, the latest released version of that provider. And Terraform allows it to mark certain levels as beta versions, and then you can specify this beta version in your code if you want to test that. But usually when they then gets to a GA release, the tags are changed, and then it will be automatically downloaded and updated when you tell Terraform to use the latest version of the provider.
Got it. Okay, cool. So really flexibility from the kind of users end and the developers end. If they want to provide feedback into it, they can, and users they can select which build they want to actually download and use in production or in test or whatever it might be.
Yeah, that's of course important because it doesn't happen very often, but from time to time there are some changes in the way the objects work and the objects format that you need to configure in the Terraform file. And sometimes, of course, that also means some breaking changes. Usually they have, when you use the release notes, we will see that later in the demo as well, they mark some features as deprecated or some fields as deprecated, and it's also very well documented in the Terraform documentation for each provider and for the VCD provider as well. And therefore you can, if you have a huge amount of existing Terraform code files that you use in your automation, then it might cost some effort just to test that with newer versions, and you still can tell Terraform to use an older version of the provider that you know that it works with. So it allows a very smooth upgrade path for the Terraform binary itself, for the VCD provider, which is the component that the Terraform binary uses, and then how that aligns with your code files, with your infrastructure as code files.
Yeah, it's a good point, actually. So does anything change? I mean, you've got obviously the VCD objects that Terraform is manipulating and calling. Those are obviously, once they're in a VCD release, they kind of stay in the release. They don't ever disappear, but new things get introduced into our Terraform provider, so new support, and that's why we want everyone to be running the latest and greatest. But if I'd written a whole load of Terraform scripts that were calling objects in VCD, and there was a change in VCD, that change would be replicated in the next Terraform delivery. But would I then have to go back? I would, and edit my scripts, right, to make sure they were calling the right things.
Yeah, usually it's not really necessary because there are, actually different levels of abstraction for the the inner details of VCD. VCD itself has a very good API versioning strategy. So whenever you make any API calls to VCD, you have to specify the API version that your client works with, and that allows you to upgrade VCD even to newer versions, but still use older API clients using older API versions. And VCD itself usually has like 1.5 to 2 years of backwards compatibility for older API versions. Right. Now, for the Terraform case, it's a Go language library for Terraform that is also maintained by the same engineering team within VMware that does the actual calls to the VCD API. So this Go language binding for the Terraform for the VCD API client also has to provide the individual API versions of VCD. And that's something when you look into the logs of each call from the Terraform provider towards VCD, you see that when the first login happens, there's like some negotiation between the Terraform client and therefore the Go library for VCD and the VCD server, which of the API versions each one support, and then they like negotiate for the latest one, and then the client uses what's possible within VCD. And then from a Terraform perspective, there are these different, the syntax for the different objects and their fields, their attributes that are available that you can specify. These typically do not change very often because they always represent the same things. Even if the actual API changes, the abstraction in the Terraform file still stays the same. Yeah. That said, of course, we have some larger changes, like the change, of course, from NSXV to NSXT, where it's a pretty different object model. And then these are new objects in your Terraform files. And sometimes it also happens that from some version to another version, there are larger changes needed for the object files. And then it gets usually a new object type gets introduced with like a V2 at the end. We have seen that, for example, for load balancer objects that might have changed when you use the NSXT native load balancer and now the AVI advanced load balancer functionality. And then, but that's very well documented. But that also means that usually your older code still works. And if you want to use the latest and greatest version, then you like refine your Terraform scripts to and files to use the latest version of these objects.
Yeah, use the V2. So, I mean, that in essence is the whole form of, whole reason for Terraform is to create that abstraction, to have you kind of automate into VCD and VCD engineering to take care of the mapping, which is really cool because that's ultimately what we want. Okay, so let's talk about 3.9 then. What was new in 3.9 and what sort of functions have we developed? Because I know as we've gone along, we've built in a lot more NSXT now. It's pretty much done. And the advanced load balancer, I think, was in the last release. So what came in 3.9 that people are going to want to use?
Yeah, so first of all, for the release cycle of the Terraform provider, since it acts as a client to VCD, it is decoupled from the VCD releases. The Terraform provider and that Go language API binding uses all public available API calls from VCD. So there is no internal stuff. It uses the public available parts of the VCD API. And the team usually plans to have 2 to 3 releases per year. So you can see within the GitHub pages, the release page, that they have a pretty good schedule. And for each release, usually they have introduce, of course, new capabilities, new features, usually new objects that allow just to broaden up the functionality of the Terraform provider and the things that you can actually automate with Terraform in VCD. And then there are usually a lot of improvements to existing objects and functionalities as well. And of course, these, the requirements from that comes a lot from VMware internal teams that use the Terraform provider, but also, as I mentioned, a lot from the community who feeds back feature requests and bug reports through the GitHub issues. And in each release, there are usually a lot of bug fixes in there that really are part of the community-based open source model for the provider. Now in 3.9, the big improvements in terms of functionality for sure is the support for runtime defined entities. Runtime defined entities is a framework in VCD that allows people to build extensions and reflect or store objects in the VCD database managed by VCD. And VCD takes care of the tenancy of the access model, the multi-tenancy, and the persistence of these objects in the database. And these runtime defined entities, they are being used by the extension developers, VMware or external third-party vendor, or even partners. I think a couple of episodes ago we had a episode about the solution SDK, where
we did,
talked about that in details. And these runtime defined entities, for example, they are being used by extensions like App Launchpad and Container Service Extension. And the main goal here is to step by step get some better Terrafrom represents and functionality when it comes to container services in VCD. And now with 3.9, the first version that included, or the first phase of this support and this work now supports to configure runtime defined entities and runtime defined entity types. And that allows a user to automate the installation and configuration of container service extension. And that is something that's usually, if you do that manually, it takes a lot of different steps to deploy components, to configure stuff, networking stuff, to prepare your provider and organization VDCs for that, and then finally define these runtime entity types and create them. And the Terrafrom provider now allows you to automate that procedure. And there is some very good guidance and documentation on the Terrafrom provider homepage for that. We'll see that later as well.
Yeah, I know in CSE, I think it was 4.0, they made quite a big change from, you used to have to do a lot of CLI at the back end to deploy the actual extension. Now there's a lot in the UI. So this is kind of adding a programmatic way of deploying that if required for partners or indeed for customers and their cluster management, right? Okay.
But having the support in Terraform for the generic runtime defined entities also, of course, allows you to enable or to automate all the other extensions that use that. So you could do App Launchpad catalog management through Terraform, for example. However, since it's generic support for the runtime defined entities, it's a lot of code that you have to put in your Terraform files to make that happen. So it's first phase, but for sure in future, we want to make it, especially for the container service extensions, more easy for especially tenant users to consume the resources and to create and consume the Kubernetes clusters as well.
Okay, great. Well, should we dive into it? Let's have a little look at what's going on in 3.9.
Yeah, absolutely. So let me switch over to the demo. Like steps is for each new version, the official Terraform provider documentation on the HashiCorp homepage and the GitHub repository for the open source project. And the content here actually is part of the GitHub source code repository as well. But of course, here it's much nicer to consume. And you can see for the latest version, the different notes and guides, how to use it, how to get started. We have a section for specific guides where, as I mentioned, for the new support for container service extension, CSE 4.0 is in there. And there you can see it's a pretty extensive and long guide how to use Terraform to install and configure container service extension.
Okay.
And there are some other examples in there as well. For example, for the NSXT advanced load balancer, some guides for roles management and for the VDC groups, guest customization, things like that. So these are guides that are like end-to-end user guides. And then we have the more technical references for the individual resources and data sources. These are now parts that you put into your Terraform file. And there you can see like the reference, some examples for each of the resources, and then the actual argument reference, so which fields are available for each object. So that is something for whoever creates the Terraform files, you will spend a lot of time in that documentation to figure out the different fields.
Absolutely. You're just thinking the entities that we're now enabling in terms of the plugins. Is this something that could be used by, you said app catalog and other extensions, but could this be used by third-party vendors as well?
Yeah, absolutely. So the runtime defined entities API is part of the public API in VCD and can be used, for example, by, I would say, perhaps by backup vendors to store information about backup configuration, or for object storage extension, of course, not for the object data itself, but perhaps for some metadata around the buckets or anything like that. So that's all things that could be used by third-party vendors who want to integrate their system with VCD as well.
Okay. Something to talk to the vendor ecosystem about as well, then.
Yeah, absolutely. And with the support in Terrafrom, that allows then the provider to automate these kind of things as well.
Okay.
Yeah. For example, some example going back to the documentation, where we have for isolated networks and then isolated networks version 2, that's like the different where they have huge changes from NSXV to NSXT, and therefore new objects got introduced with new fields.
Yeah.
Okay. Then if you want to look at details for each release, that's part of the GitHub repository. So the Terrafrom VCD provider repository on the VMware section. That's where you can find, well, of course, all the source code of the Terrafrom provider itself, but also information about the individual releases. And that's here on the right-hand side in the releases section, where you really have for each version the new features that got introduced, the improvements to the different fields, bug fixes usually related and linked to the different issues that are reported, and if applicable, some special field about the deprecation, where you can see here now that some fields got renamed in this case. So that's something where you really would have to change your code and do a search and replace for the fields.
Yeah.
And then some additional notes for each of the releases. And these release notes, or these release notes and the changelog you can see for each version, even for the 2 different beta versions I think we had, and of course for the older versions as well.
Okay. And you can obviously download the version from there, right?
Yeah. So if you want to contribute, of course, that's usually mainly part through the issues section on the GitHub repository, where you can see it's a pretty active community. There are, of course, VMware engineers monitoring and responding to the queries there, bug reports, feature requests, things like that, guidance that you get. We have the pull requests. That's if you want to really contribute some code, you can download the source code repository and then read through the README on the main page. That's a description how you develop the provider and build the provider on your own system and then contribute the code. However, as an end user, you usually don't have to touch that at all. As an end user, you mainly work with the examples and the description and the reference in the documentation, and then, of course, your Terraform files. There's just one thing that I want to show you because it's super helpful. In the source code, there is one folder with examples, and that examples contains really 4 different use cases, some almost ready to use Terraform files that you can start with. So for example, for like NSXT resources, there are some examples in there for IPsec VPNs, some other ones that you can open up, and then you can see the example of the Terraform file with the details and the different code in here. And we actually will use an example from there in today's demo for the catalog publishing subscription. That was some feature, I think, that was released in 3.8, so the last version, VCD, to improve the catalog management, the automation of that. As I mentioned, usually as a user of the Terraform provider, you don't really have to look into the source code here. You mainly use the issues to get perhaps some help or to file some enhancement requests. Okay.
There is a public Slack channel on this as well, right?
Yeah, absolutely right. On the if you go to the code.vmware.com homepage, and then from there, there's a link to the Slack community, and there we have the Terraform VCD channel. I think it's mentioned somewhere down here as well. Okay. Let's have a look into the first example where we use the Terraform provider to automate the creation of a catalog, publishing it as a provider, and then from another tenant, I want to subscribe to that catalog. Okay. So for that, first of all, let's have a look at the source code file. So I'm switching over to my text editor. In this case, it's Visual Studio Code, but you can do that with any text editor that you want. The Terraform files, they use this syntax, which is specific to Terraform, but it's a text only. So you can use any text editor to edit and maintain these files. And what we have here is some example for publishing a catalog. And in this example, it's like a full end-to-end example. So it also explains, or I'm going to also explain how the provider is being used for some of the basic stuff like authenticating against VCD and making the connections. So first of all, you can use different variables in your Terraform file and store these variables in a different file. And the idea behind that is that usually, well, it's infrastructure as code. So that means your Terraform files with the ending TF itself, you usually store them in some kind of source code repository so that you have change control, that you can collaborate with people, that you can align or mark and tag different versions of that file. And that also means that you usually don't want to add some sensitive information like passwords into the source code repository. And therefore, you Terraform allows it to define these variables, and then you have a file that's called tfvars, and that tfvars files contains the actual content with the super secret password and the environment specific information that you don't want to add into your source code repository.
You expect there that you want to kind of take advantage, and correct me if I'm wrong, of the new VCD service accounts.
Yeah, that is something for the Terrafrom provider. And I think going back to the documentation, which is documented at the very top level on the main page, all the different usage, how to log in, and we will see that in the demo in a second as well. So you can the idea is that you can use the Terraform provider both as a provider and as a tenant user, as usual. Well, it of course reflects one of these big paradigms of VCD, that we have that separation between system administrator, provider administrator, and the organization or tenant user and administrator. And the Terraform provider works with both. So you can log in as a tenant user or as a provider user, and of course automate the stuff that is, well, within your range of possibilities. So for a provider user, some use cases would be, for example, onboarding or configuring organization VDCs, onboarding new tenants. That's something that we had good examples in the older episodes about Terraform. If I remember correctly, that hasn't changed a lot. Of course, the fields have changed a bit, and the possibilities for the organization VDCs, but the concept still is the same, that you use Terraform to create an organization, to create edge gateways, connect, define organization networks and stuff like that. And then, for example, as an org admin or a tenant user, you would use log in with your tenant credentials and then consume the resources, create vApps, catalog management, for example. That's something that we are going to do. And as an option here, you not only can log in with username and password, but you also have the fields to log in with API tokens. So that's the API tokens that we introduced in 10.3.1, where you create as a user, you create a token that allows a client, in this case Terraform, to mimic this user. So all the tasks that you would do with Terraform would be called by the user who created the token. And then it's also possible to use service accounts if they are already registered. And you can find some example in here to use, or how to create, well, service accounts and then use them from the Terraform provider.
Yes, I think if you're doing a kind of one-off job and you just want to kind of create something in Terraform, then go ahead and use a normal account. But if you're doing a production system and you're going to be running this again and again and again, then use the auth token and service account for sure, right? It's best practice in case that user you're using changes for any reason.
Yeah, absolutely. And we can see here in the example, it actually contains all the possible fields. So you, first of all, tell VCD to use the Terraform provider. That's like line number 8 here with the provider VCD. And then it's the configuration to the URL, so which is the VCD endpoint, the organization, or if you want to log in as a system administrator, the system organization, the VDC that you are working with, if you want to specify some objects. And then on the top here, well, username, password, API token, or the token for the service accounts. It even supported for SAML authentication. So if you configured VCD to log into an external identity management system, that's supported as well. And that's all defined based on the different options that you have here for the authentication type. Now, in VCD or in Terraform, it's all text-based, but if you use like a development environment like Visual Studio Code, it automatically reads from the documentation, from the HashiCorp or the Terrafrom homepage. And if you can see here, for these examples, if I just mouse over for the authentication type, it tells me automatically which of these strings are possible. So integrated for built-in user integration, you can have token, API token, service account token file. That stuff that you usually, if you don't use, or if you use a plain text editor, you would always have to jump back and then look at the reference here to figure out what the possible values for the different things are. It's pretty convenient here to have a development environment for you.
Yep, definitely.
Okay. Yeah, then some configuration of the logging. If you want to do that, that helps you because it really gives like each individual API calls that the Go language binding makes to VCD. Very helpful for troubleshooting. And then, yeah, for the catalog example here, where as a provider administrator, I want to create a catalog, upload some OVA and ISO files, and then publish them. And then from a different organization, I want to subscribe to that. There's some data that's needed from the environment. So since, well, in Terraform, the main concept is to have infrastructure as code, so that you define your infrastructure in the Terraform file. And usually, well, the Terraform file should be the source of truth for all changes. So when you make some changes, you usually don't want to make them in VCD directly, but you rather want to make the change in the Terraform file and then do a Terraform plan and the Terraform apply again to let Terraform make the changes. However, in some cases, or a lot of cases, for some automation to work, it does need some information about the environment. So for example, if you want to create a catalog, one of the input fields when you create a catalog in the VCD UI is to select a storage profile where the catalog item should be stored. And that, of course, is environment specific. And that's something that is used in Terraform with these data fields. So that is something, some objects that the Terraform provider reads from the environment and allows you to use in the Terraform file to get some environment specific information in there. And you can then use this information in a later step, for example. So here I read the storage profile that's available in VCD, and then I use that later in the resource when I want to create the catalog. So that's like how Terraform works with environment-specific information. And for the provider in VCD, that's where you can see in the documentation resources. That's the stuff that, or these are all the different objects that Terraform can create in the endpoint in VCD in this case. And data sources, these are all the different objects that Terraform can read from the existing environment. And usually there are a lot overlapping because the code is pretty much the same, no matter if you, well, if you make some changes in the VCD API, you do like a post or a put REST command to create an object, and then a get command to get the same object back. So it's pretty much comparable effort for the developers to create these data files or data sources. There's a long list of the available data sources as well that you can use to read existing environment state into your Terraform environment.
Yeah, and each release just extends those kind of data sources and the amount of objects that we can publish to as well. Yeah,
and that's what we've seen in the documentation for these release notes. All the new objects for data sources, new resource elements that are added with each version of the provider.
Yeah, cool.
Okay. Then we tell Terraform to create a new catalog here with the resource block, and then all the information about the catalog to create. So the name, description, some metadata that's available, and then the support for publishing the catalog. So these pretty much reflect API calls that you would make if you want to do that without Terraform manually to the VCD API. And then once created the catalog, we also want to add some items to that catalog. So that's something where we can use the object VCD catalog vApp template and VCD catalog media for the ISO file. So in this case, I use some OVA files that are locally on the system where I run Terraform from. And one is just a small, I think 3 VM OVA virtual app that we want to get into the catalog. So it's getting uploaded from the system where I run Terraform to VCD. And the same for the ISO file, some small ISO file that I have here. You can do in Terraform, that's pretty convenient count. So you can do that multiple times and tell Terraform, please create me X amount of objects in the backend system. So in this case, it will create 2 catalog items for OVA files and 2 media items with the ISO files. Later, we can see in the tenant examples that you can use that for different creating multiple virtual machines at the same time, for example.
Right.
Yeah, and then there's some output definition that tells Terraform to get values that are being created while the automation is running, and get these back to the caller. So they will be shown in the command line, the output information, and you can use them if you do some more complex automation in some later steps of your automation. And in our case, the most important or the interesting one is the publishing URL, because that's something that is automatically, dynamically created when you create a catalog. And we need that publishing URL later in the next step when we subscribe to that catalog. So it's an example on how you pass information from one step of your automation to the next one. Here for the catalog URL, usually when you do that as a tenant user, you would do that, for example, with IP addresses that gets assigned by DHCP or by IP pools in VCD. And then you want to use these IP addresses of newly created virtual machines in a later step to, I don't know, log in via SSH and push some code for testing or deploy some application or some other functionality into that virtual machine using the IP address. Okay. Then let's switch over to the terminal. And here, that's like plain old terminal. I am in the directory that's also shown in the code environment. So let me go to the publisher directory where we have the file, and Terraform automatically reads like all the different TF files in one folder, and then uses all of them as one environment. So you can structure your Terraform files in different sections or have one big one depending on how you want to work. To install Terraform, that's pretty easy. That's something I'm not going to show here. It's one binary that you download. So it's an exe file on Windows or a binary for Mac and Linux. You can use some package manager if you want to, but usually it's super simple to just download that single file. Okay. And then put that somewhere where the path variable can read it, so it can run it from every directory. I'm just doing a Terraform version here to make sure Terraform works. So it works with the, I think, latest version. And then I can do a Terraform init. So that's the first step that you do in each environment, so in each subdirectory. And this Terraform init now reads through your Terraform files. It figures out, we have defined, if I'm switching back here on the top, we have defined in the Terraform file that we are using the VCD provider for Terraform. And then it automatically downloads and installs that Terraform provider into the directory. And you can also see, if you had a sharp eye for the folder structure, that Terraform automatically creates a new subdirectory with the .terraform name in that directory. And then you, it installs the provider in this directory. So in Terraform, that's just the way how Terraform works. Everything like one environment state is local to one directory. That's also why you usually, as an example in the git ignore file, you tell git to not put this into the repository because that's really environment specific. So these .terraform files.
Simple.
Right.
Yeah.
Getting back here. So Terraform, yeah, put in all the stuff that we need for this to run. And now let's do a Terraform plan. That now creates, like compares the existing state in the environment with the state that we want to have and tells us what it would change. And now let's see, it reads through the Terraform file, it connects to BCD, and then it tells us, yeah, what resources it would add and which one to change, which to destroy. In our case, it's 5 to add, and you can see here in a JSON format the new resources. It's 1 catalog and 2 templates and 2 ISO files. So these would be the stuff that's going on here. If you do a Terraform plan, it already it already connects to VCD. So if you have if something is wrong with your authentication, you would get some errors already in the Terraform plan stage.
And it's telling you there that one of the object names you're using has been deprecated, but it will still work. Right?
Exactly. So that's pretty cool with Terraform, since it uses that open source model that whoever develops the provider, in this case our VMware engineers, they can mark the different fields in the source code as working, as deprecated, and whatever. And then the Terraform binary, as a user, you don't have to look into the source code to get that information, because the Terraform automatically reads it from the source code, and then it knows, okay, well, this catalog, information is, the field is outdated. In future, use catalog ID instead of the catalog field.
Cool.
Okay. Then let's do a Terraform apply. And this is now, it runs the plan step again. So it checks the existing environment against what's described in the Terraform file, and then asks me, do I really want to make these changes? Yes, I do want to make them. And then it really automates to change the physical environment with what's configured in the Terraform file. So it will create a catalog and upload the items. That's something that's happening here in background. While this is running, we are going to switch over to the corresponding portal in VCD. Just checking. We are in the publisher section. And for the Terraform variables, I'm working with the Piper organization. Let's log into VCD as a provider. Recognize the new branding features.
Oh, love it. Yeah, fantastic. Well done.
I'm logging in as a provider, and then I'm going to switch over as a provider to the Piper organization.
And as well as it logging out to the Terraform log that you specified in the config files, it'll also log into VCD, right, as the objects get created.
Absolutely, and that is something that you would be able to see. Let's see, we are in the publisher phase. So you get the Go VCD log file that's growing quite quickly, and that's where you have, depending on the log level, a lot of information of each individual API call. Okay, let's see with the running task, we already can see the different tasks running for the catalog creation, and currently it's uploading the OBA files and the ISO files. That will take some time. As a provider, you already can see this. And in the Piper organization, I want to show that, the actual catalog gets created and the media items get created.
I'm loving the demo of the branding here, Joerg.
Okay, switching over to libraries. And then we get into catalogs, and you can already see here, there's a test publisher catalog. That's the one that we created through Terraform. In here, I'm not sure if it shows the items already. They're being, it shows them, so they get counted through. So that's test 1011. That's the stuff that's being created as part of the Terraform file for the publisher. That's the information that we have in here with the test name and then the count index, since it iterates like a for loop for how many items you want. Okay, this is still going to creating. So in the command line, it tells you like the steps where it is. Yeah,
that might take a little while.
Okay. Yeah. Meanwhile, I'm going to switch over to the subscriber model. So that's going to be pretty much comparable. So I log in again, this time from in another subfolder. I log in to VCD, and then I'm subscribing to a catalog and just defining that the catalog. And the idea is that we use the subscription URL. That's something that I have to change now, which I get from the publishing information. So for the Terraform variables in this subfolder, I'm now logging into the eCorp corporation, and let me check that. That's a different tenant. So I'm logging in as a tenant user, just to show that we don't have that catalog subscribed yet. Switching over to libraries here, and then to the catalogs, where we have the two default catalogs. And what I'm now going to do, we can see back in the command line that it finished completely without any errors, and it got me back the publishing URL. That's like the stuff that I now have to copy and paste that in the subscription URL of my subscriber Terrafrom file.
And I assume this can also force a sync of things like that between different VCD instances, right?
Yeah. To paste that in here.
Okay.
Save the file, and then going back to the command line. And now I have to change over to the different subfolder again in here. That's like for the subscriber demo. Again, in Terraform, everything works within a directory. So I have to do all the process again with Terraform in it to initialize the VCD provider. Then I can do a Terraform plan. With want to add, and I can do Terraform apply. Now it's going to subscribe to the catalog with the settings configured in the Terraform. And if something is wrong, like the URL is not valid, we would get some errors then. In this. And then switching back to the tenant here, I'm going to refresh. Let's see. Eventually, the new catalog, the subscribed catalog, will show up.
Very cool. There it is.
Here it is. Remote subscriber. This is one example how you can use Terraform to, in this case, publish, subscribe to catalogs. Something that seems to be rather simple. So if you look at the Terraform files here, the individual ones, they are not that complex. It's rather a few lines of code. However, that is a task that as a service provider, you usually do very often, or you want to automate because you want to do that for new versions of your catalog items, new catalogs, new like functionality apps that you want to offer. And of course, you want to publish that to new tenants that you onboard. So it could be a part of your tenant onboarding process to subscribe to catalogs as well.
Yeah, absolutely.
One of the things where,
I mean, just from this catalog piece, you're absolutely right. That is something that, everyone does, right? So it's going to be something that if you can do it via Terraform and do it programmatically, be a checkbox in the onboarding. Do you want these catalogs, and off you go. Yeah.
Mm-hmm. And that's something where, well, we have in the older examples, or when we had the example with NSXT, it's a lot of long lines of Terraform files with very complex steps to do all the network automation and things like that. That's of course worth to automate, because then you minimize human errors if you want to, if you do that automatically. But even the rather simple steps, that's like one wizard that you have to click through in 3 clicks, you can do that as well in the UI. However, it's a task that's very common, so that's another very good candidate to automate.
Yeah, and when you say, you know, you're onboarding a customer, and you know, maybe you've got, I mean, in reality, right, your vApps are going to be pretty large, because they're going to actually be full OSs most likely. So, you know, you need to kind of provision that when you say onboarding, you know, your environment will be fully ready within 12 hours, sort of thing. That's or you do the syncs at night and you know, make it a lot kind of easier on the bandwidth. You got full control there, and you're never going to make a mistake, because it's going to be the same process again and again and again.
Then let's move forward to the last demo that I want to show you. This is now really as a tenant user. So again, single Terraform file. Here as a tenant user, I'm really, if I look at the TFRs, logging in again as a tenant user to VCD. And in this case, I want to deploy a new vApp, create a new vApp with 3 virtual machines, some network configuration for the virtual machine. So it's like a multi-tier application with a web database server and 2 web servers as front end. So we have the definition for the web server, count 2 here. In my case, just for the demo purpose, I'm creating empty virtual machines. Usually would deploy them from a catalog, from an OVA file. You can add ISO files, whatever. That's like your VM creation automation. There's, when you look back at the example, there were some good description on the documentation getting up here about how to do guest customization. So that's pretty important to read through, rather if you use Cloud Init or the vSphere guest customization, how you create your virtual machines and automate them to get, well, an identity, IP addresses, stuff like that.
Yeah.
And then, we create some security groups around these new virtual machines. In my case, I don't have a VDC groups and a distributed firewall activated, but that would be a block, just as an example, how you can create firewall rules through Terraform as well. In my demo environment, I don't have that configured, so it's commented out here. And then we want to configure the load balancer to create some service, virtual service for the web servers, and like do some load balancing between the 2 web servers here.
I just want to point out here, so when you consider security and security challenges and problems that people have, I think there's something like 90% of them are due to human error, not to the actual kind of capabilities of the software. So having this done programmatically is key to avoiding, you know, security issues where distributed firewall wasn't enabled, for example, or it was enabled incorrectly. And also, if you use vSphere tagging in your OVAs, you could then just put these into a dynamic firewall rule in VCD as well. So you don't actually need to worry about that so much. As long as the dynamic firewall has the condition for the tagging set up, it'll automatically detect the VMs and start protecting them.
Yeah, and that's something, the whole idea behind infrastructure as code is that you add the information about the architecture and the layout of your infrastructure, all the different VMs, like here the 2 web server VMs and the database server, as part of your source code repository. So if you develop and create new versions and you test that or deploy a new environment, you already have the specification in your code and have Terraform automating that. So that means it's the security and the firewall rule creation and the load balancer creation automatically is part of the deployment of each test environment, of each production environment that you might deploy from your code. And that's something, of course, that allows the application developer team to already like bake in the security information and the firewall information, the outbound connectivity information. into the description of the infrastructure that gets deployed with each release. And compare that to older versions where you always had to talk to the firewall teams. Well, I deployed a new test environment with my 3VM. Can you please create three firewall rules, or even do it manually even in VCD as a tenant user? If you do it manually, you tend to forget it, or it's just much more error prone than if you put that into automation into Terrafrom.
Yeah, I mean, the opportunity here to kind of establish a zero trust baseline for your tenants is like really real if you're starting to use this to do tenant delivery, and the tenants using it indeed as well. But yeah, I just want to point that out because I think there's not enough partners using distributed firewalling and dynamic firewall rules to the extent, like you say, they're still using physical firewalls and reloading firewall rules manually and things like that, and it's pretty ugly. But this can take away a lot of that headache.
And not only for you as a provider, but also, as you can see here, it makes it very easy for your customers, for your tenant users, to consume the firewalls, because it can be part of, well, a definition in the code, and it always gets automated with each deployment. So even your tenant users don't have to manually configure these rules and add all the necessary steps to their deployment program.
Yeah, absolutely.
Okay, let's give that a try. Switch back to the tenant folder. Again, new folder. I have to do Terrafrom init again. I'm going to do a Terrafrom plan and see that, I already have some attributes in my plan that are, duplicated. So that's something based on my code copying between different environments. That's a good thing. If you do a Terrafrom plan, it already checks like the syntax of the Terrafrom code. And then it defines if it's there or not. So it's line 32 and 33.
You can just remove them, can't you?
Yeah.
So we're already set.
Up here.
There you go.
33. And I'm going to delete them. Save that. Do that again. Let's see if we have some other syntax errors in there. Oh, that looks good now. So at least from a Terrafrom perspective, from a syntax perspective, it's correct. So there are no unknown fields, no typos in the field names, the resource names. Of course, there is still a lot of stuff that can go wrong when we do Terrafrom apply. That's then now based on the actual configuration in VCD. So here we get 9 to add. That's 3 virtual machines, bunch of network configuration, load balancer configuration, things like that. I'm going to do yes here and start that, because that will run for a few minutes as well. And now it's creating the demo vApp, and it's going to create the virtual machine in the Stark
that's right.
client. I'm going to log into that one quickly, and then we can see the vApps being created. VMware Cloud, looking at the vApps, you already can see we've got the Feature Friday demo that's being created in here. And with the time, we get more and more virtual machines added in here.
Yeah.
And then there's also, go ahead.
I said that's brilliant. Yeah, absolutely. Brilliant.
Yeah, and then we can also see in the like the networks and the edge configuration for the gateway in the load balancer settings. So there are some the service engine group that's predefined that we are going to use, and then we have pools for the existing environment. So that's the existing different pools that have been created from past demos and virtual services. And then when everything goes right, we will see a new pool of VMs or pool of servers for the newly deployed web front-end servers for the 2 of them being created here, and then a virtual service that configures the load balancer to connect HTTP round robin to these 2 web servers as a front end. But that only happens, of course, once the VMs are being created, so that it's going to take a while.
Yeah, no problem.
So that's something in general in Terraform. Terraform creates like a tree structure of your Terraform files, and you can so for all these like top level objects, it creates a tree structure of them, and you can define some like dependencies in between the different connections. So here, for example, the web servers and the database servers, they are independent from each other. So in theory, they can be like deployed at the same time. There are some challenges when it comes to vApps with VCD because of the vApp construct, because you cannot have two automations changing the same vApp at the same time. But you can, for example, if you create, well, the VMs, that's one step. Meanwhile, the security group can be created in NSXT. That's something that's independent. And then for the next resource to create the pools, for example, that's something that cannot be done at the same time, because here we have some dependencies on the IP address of the VM that gets assigned by, in this case, it's pool-based, so gets assigned by VCD. But that's something that Terraform does automatically. And if you look at your automation, well, it's automation, so typically the actual performance does not matter that much because it runs in background anyway, in the same way as we have it running in background as well. But if you want to, or if you need to optimize that, then have a look at the Terraform dependencies, how Terraform defines and calculates these dependencies, and then you can see what you can parallelize. But Terraform actually, when it recognizes that stubs are independent, it already makes these calls in parallel. So it's already pretty
that's
performant.
pretty smart then. So it kind of looks for, I see.
Yeah, and now we can see here that everything got created correctly. So let's switch back to the configuration and the different settings here. So I'm just going to, reload that page for the pools.
There you go.
And we now should have a new pool, server pool being created. Yeah, we got the web server pool. We added, see the settings here with the members. These are our two new virtual machines with the IPs for the front ends that have been created as the first part of the section. And then the virtual service group, that's the new demo with the HTTP round robin to these two web servers. And that's something that shows pretty nicely how you can create vApps as a tenant user programmatically with Terraform, and also configuring your firewall rules, your load balancer configuration, and store all that information really as part of a single file, and add that to your source code repository. And therefore, whenever you deploy that again and again and again, it really takes all the steps necessary and will deploy test environments, production environments for each of new release cycles at the same time, without any human errors in between.
Unless you've made a mistake in your files, obviously.
Yeah, of course. That takes some time. So you will see, especially when you have dependencies like the IP addresses, things like that, it takes some time to develop these Terraform files. But once you have them, they run very stable and very, very reproducible. Yeah. If you don't have any larger changes in the environment.
You definitely see it as a high value item for cloud providers for like onboarding and service activation, and for tenants, if they're doing a lot of development work and require multiple environments again and again and again. This is a fantastic solution. All right, well, thank you, Joerg, for showing us that. I think it was that was a pretty full demo. We saw it completely end to end there. So thanks for the recap about what Terraform does and how it behaves within BCD. I think the advice here is to kind of take a look at the websites that we've shown, see or have a think about what it is that you're actually manually doing today, the same thing over and over again, and then look to see if those objects are available in Terraform, and then get at it, start programming it.
Also make sure to have a look at the code.vmware.com page. In Sample Exchange, we have some samples of these Terraform files that get you started. And well, since it's a single binary, the entry level or the entry effort is pretty low for Terraform. That's super nice. So just start automating your environment.
Brilliant, brilliant. Joerg, thank you so much for today. I really appreciate all your time and effort in setting up those labs. I know that takes quite a while, so thank you. Yeah, to our partners watching, then please reach out to the Slack channel if you have any issues or questions. But otherwise, pretty much follow what Joerg's shown us in the demo today. Thanks a lot, Joerg.
Yep, thanks.